Hello, welcome to this second video for lesson 1-1 for algebra. Yesterday we talked about independent and dependent quantities, or variables you might be used to calling them in your science class. And we're just going to expand on that, and we're going to look at some graphs and some characteristics of graphs to match the situation. What I asked you to do for homework yesterday was cut these graphs out of your textbook, pages 11 and 13, because we're going to take these graphs and figure out which situation they match. Okay, so Candace is a building manager for Crowley Enterprises office building. One of her responsibilities is cleaning the office building's 200-gallon aquarium. For cleaning, she must remove the fish from the aquarium and drain the water. The water drains at a constant rate of 10 gallons per minute. So last class we already talked about that the independent quantity would be time and the dependent quantity would be the water in minutes. So now we have to go back and reread the question and look for details that help us pick a graph. Well, a couple things, a couple key words. First of all, we're talking about water draining. So for me, I'd be looking for a graph that's going down, that is decreasing. The other key word that stands out is constant rate. That means that the rate is not changing. So I should be looking for a graph that goes down as a straight line. So if I'm looking through my graphs, the one that goes down in a straight line is graph H. So I'm going to mark an X through that I used it already. And we're going to, now in class, what we did was paste these in on the page. So we pasted in graph H. The other thing you're doing is labeling the graph with the independent variable across the bottom, and the dependent variable on the side. So you're just taking these labels here that we already figured out and putting them on the graph. Okay, so let's read the next one. Smartphone, but is it a smart deal? You've had your eye on an upgraded smartphone. I'm just going to change the view a little bit here. There we go. Currently, you do not have the money to purchase it. Your cousin will provide the funding as long as you pay him interest. He tells you that you only need to pay him $1 in interest initially, and then the interest will double each week after that. You consider his offer and wonder, is this really a good deal? Alright, well, we're really not answering that question. So yesterday we came up with the independent variable of time and the dependent variable or quantity as interest. So now we're going to go back in here and we're going to look at some keywords. First of all, if the interest is doubling each week, that would be a clue to me that my graph is increasing. And I need to look for a graph that's going up. Now, it's not going up at a constant rate because the first week it's $1. The next week it's $2. The next week after that is $4. The next week after that is $8. So every week, it's more and more and more and more. It is not increasing the same amount. We're not counting by 2s. We're not counting by 4s. Every week is more and more and more. So this graph will not be a straight line. So we're going to look for a graph that goes up, but not a straight line. Okay, so that means graph A is not it. So graph B, okay, we start off not paying too much interest, but as time goes by, we're paying more and more and more and more as we go up. Okay, so graph B is the one we're going to take, and we're going to glue that one onto this page, and we're going to label it time in weeks across the bottom and interest in dollars on the side. Can't wait to hit the slopes. Andrew loves skiing. He just hates the ski lift ride back up to the top of the hill. For some reason, the ski lift has been acting up today. His last trip started fine. The ski lift traveled up the mountain at a steady rate. Okay, so right there it makes me think steady rate means a nice straight line. We're going up the mountain, so I want an uphill line at about 83 feet per minute. Then all of a sudden it stopped. It stopped. So I'm looking for a graph that changes and shows Andrew sitting there waiting for 10 minutes. If it's not going up the mountain, it's staying in one place. And then finally, the ski lift began to ascend, which means go up. Ski lift began to ascend up the mountain to the top. So here's our independent and dependent. So what we're looking for is a graph that goes up and then stops and then goes up again. Okay? E and G go up and then stop and go up again, but E looks like it's going to have some extra information in it. It's not E yet. Okay, so we're going up the mountain, we get stuck for a little while, and then up the mountain some more. So graph G, based on the clues, is the one we're looking for. And again, we're labeling it time in minutes and distance in feet. It's magic. The amazing Aloysius is practicing one of his tricks. As part of his trick, he cuts a rope into many pieces and then magically puts the pieces of rope back together. He begins the trick with a 20-foot rope and then cuts it in half. He then takes one of the halves and cuts that piece in half. He repeats this until he's left with a piece so small he can no longer cut it. He wants to know how many total cuts he can make and have the length of each remaining he can make and the length of each remaining piece of rope after the total number of cuts. Okay, so if he makes no cuts, the rope is 20 feet long. If he makes one cut, it's 10 each piece. If he makes two cuts, each piece is going to be, no, it cuts in half. So he's not going to make two cuts. He's going to make cut in half, then cut in half again. That's three cuts, and each piece is 5. Okay, so let's draw this rope. Okay, one cut makes two pieces, each one being 10. Okay, then he takes each piece and cuts it in half again. So now that's a total of 3 cuts. 1, 2, 3. 3 cuts, and each piece is now 5 feet. Okay, 5, 10, 15, 20. If he cuts each piece in half again, we've got the 3 original cuts plus 1, 2, 3, 4 more cuts. So that's 7 cuts, and each piece, let's see, we've got 8 pieces, that's 2.5. Okay, so and then each piece after that gets smaller and smaller and smaller and smaller. Okay, so if we go back, and to be honest, this side is not really that important. It's the half each time. So half of this would be 1.25. Half of this would be 0.625, and so on. So we're starting off with 20. Half of that is 10. So we have a loss of 10 feet. But this time we only lost 5 feet. This time we only lost 2.5 feet. This time we only lost 1.25 feet. So the amount of rope we're the size of the rope is getting smaller, but it's it's not as dramatic each time. So we're looking for a graph that goes down. A graph that goes down, but in a curve way. Okay? And really the only graph that's left right now that even kind of remotely matches that is graph D. graph D. And then we're labeling that with our independent and dependent quantities. Baton twirling. Jill is a drum major for the Altadena High School Marching Band. She has been practicing for the band's halftime performance. For the finale, Jill tosses her baton in the air so that it reaches a maximum height of 22 feet. This gives her 2 seconds to twirl around twice and catch the baton when it comes back down. Okay, so we're looking for a graph where we've got a baton that goes up and then it comes back down. Well, that graph, there's really only one that looks like that. Okay, graph F. Nope, too far. And we're labeling our independent and dependent variables. Jermaine loves music. He can lip sync almost any song at a moment's notice. He joined Songs When I Want Them, an online music store. By becoming a member, Jermaine can purchase just about any song he wants. He pays $1 per song. Well, that's a rate. And anytime we're talking about a rate, we're going to be talking about something that is a line. Okay? And we have our independent and dependent variable. If it's a rate and it's a line, okay, the more songs he buys, the more money he is spending. So when we look at our graphs, out of what we got left here, looks like graph A is the one we want. It's the one that's going up at a constant rate. Okay, number of song, cost per dollars. And even if you look at the graph, if we assume, which we can't always do, but it kind of looks like the number of songs, this would be 1 song, 2 songs, 3 songs, etc. $1, $2, $3. It's not labeled that way, but that could help us pick that graph as well. A trip to school. Monday morning, Myra began her 1.3-mile walk to school. After a few minutes of walking, she walked right into a spider web, and Myra hates spiders, so she began to run. Okay, so if you picture what's happening, walking would mean like a steady rate of speed, and then she changes her speed. Okay, speed is a rate. Rates are lines. So she began running till she ran into her friend Tanisha. She stopped and told Tanisha, stopped. Okay, that's a key word right there. Alright, so let's go back and look at our keywords. She was walking to school. Then she began running, so it should be a little bit faster. Then she stopped. Stopped means I'm probably going to look for a flat line, and told her adventures of the morning in the icky spider's web. And then they went back to walking again. So if we look at the graphs that are left, there's only graph C and graph E. This one seems to follow that, walking along, oh, go faster, stop and talk to the friend, and then keep walking to school. So graph E is the one that makes sense. Labeled with our independent quantity of minutes and our dependent quantity of miles. One more. Mr. Wright judges the annual jelly bean contest at the summer fair. Every year he encourages the citizens in his town to guess the number of jelly beans in the jar. He keeps a record of everyone guesses and the number of jelly beans that each person gets guess was off by. Now, if we're talking about the guess being off, okay, just being off, if it's 2 less or 2 more, we don't consider those values positive or negative. It's just 2 off. The direction doesn't matter. Okay, this is also the last one. So by process of elimination, you're probably down to just this graph. And when you think about it, this graph makes sense. So if the person is not off at all, in other words, this point down here, and I'm going to switch colors so it stands out a little better, this color, this dot right here, that would represent guessing exact amount. Okay? Now, I'll assume that this dot right here means one less, and this dot here means one more. They're off by one. Okay? But off by one less, off by one more, you're still off by one in either direction. So that's why it's making that V shape. Off by two less, off by two more. Okay, it's making that V shape. And don't forget to put in your number of jelly beans guessed for your independent, and you got your dependent variable. Let's talk about the homework a little bit. I cannot stress enough how important it is for you to do the vocabulary part of your homework. And the vocabulary section is, you know, they try to change it up and be different each time. Sometimes they want you to define something in your own words. Sometimes they ask you to look something up in the glossary. Sometimes it's matching. Sometimes it's fill in the blank. But the bottom line is, in this course, vocabulary matters a lot. If you don't know what the question is asking for because you don't know your vocabulary, you can't answer it. And it might be an easy question if you just know the vocabulary. So this is not optional. You need to do the vocabulary. This says write it in your own words, which means I don't want you going to the glossary in your book, looking up the words and copying. Paraphrase, please. Use the notes. Use the way I've explained things in class. You know, use your own words. Then for problem set 1 through 6, you'll notice that problem 1 is already done for you. That's pretty common in this homework set, is that the first problem in each section will be done for you. Most of the time, the way that the book is doing things is exactly what I would have you do. Sometimes they go overboard and have you do extra steps that you really don't need to do, and once in a while they don't do all the steps I think you should do. But for today, this example is exactly what I want you to do. I want you to state the independent quantity and the dependent quantity by reading each question for 1 through 6. Then the next section is kind of like multiple choice. So I'm going to read the problem. Kylie is filling her backyard pool to get ready for the summer. She's using a garden hose to fill the pool at a rate of 14 gallons per minute. Well, unlike the fish tank in a previous problem that we talked about, we're not draining it. It shouldn't be going down, it's going up. Okay, so it can't be graph C because that's going really steep down. Graph B has this flat spot in the middle, and there's really nothing in the context of what they tell us in the question that would indicate that there was a reason for there to be a flat area in the graph. So it's not graph B. Graph A is the one that's increasing the whole time. Okay, so you just circle that and move on to the next one. And in this last section, all you have to do is label the graph with your independent and dependent quantities. So you can see that if the first one, Madison enjoys bicycling for exercise. Each Saturday she bikes a course and she has mapped out around her town. She averages a speed of 12 miles per hour on her journey. Okay, so key words in here are going to be miles and hour. Let me blow this up a little bit, make it bigger. Hopefully that's a little bit bigger and you can see. Okay, miles and hour. Okay, so time, dead giveaway, that's going to be our independent variable, and distance in miles is going to be our dependent variable. So that's all you have to do, is go through each scenario, read the graph, read the problem, and label the graph with the independent and dependent variables. Okay? I hope this is helpful, and I'll see you tomorrow.